Hello everyone. Hope everyone is doing good. So in this video, I'm trying to bring the intuition behind the concept agent. The reason is like actually I was on a track that like okay, let's create videos on the fundamentals of artificial intelligence or maybe the roadmap of artificial intelligence for the people those who are planning for career transition or getting started with their career. But I felt like presenting a content on the term agents will be much more relevant to the current scenario because there are a lot of content creators and the influencers like bringing different claims comparisons as well as the kind of definitions like bringing terms like there is something called agentic AI that is completely different from AI agents. And you need to learn all these patterns. But there is something we can think of like a first principle, maybe how this concept or the idea of agents have been evolved into the current theory and practice, and as well as like we can make it very easy to understand and easy to ideate. For example, if you're working in a problem where you or the company or organization would like to build an agentic system, and how would that look like? So those kind of conversation is what I'm trying to build. Agentic AI versus AI agents. And I want to put this in this way. It's like there are a lot of illusion. This is agent, this is not agent. And also we have a delusion that the term agentic AI is what the superior one, and that is the ultimate thing that we want to achieve, kind of a quasi delusion that we can say. Ideally, I want to bring this intuition so that people can really understand and work on something fundamental as well as long lasting for your like skills. So with that, like I want to like just trying to discuss what this mean, how people are really considering these terms like agent, agency, and agentic, because a lot of terms like it's see, for me it's more of the same thing that's been put in different places of a sentence as a noun or as a an adjective kind of thing, but in reality as a definition or as an intention behind these terms we can see in three different things. One is considering individuals groups as an agents, because in economics and psychology, scientists always denote individuals as an agent because it is very easy for it's more of like in a variable, right? Like for example, even though like sales or offers, all such things are there, but still we considering that as a variable. The same way we use this term agent to denote the entities which can make certain decisions or which are expected to make some decision or some task completions. And based on the level of that, based on the capacity, we say, okay, this has high agency, this has low agency. For example, like we humans, we have high agency than, let's say, some of the chatbots because we know what to do next. We are highly proactive. So, but we are also agents as well as the software programs or software agents, they're also agents. So that's why like there are three things if you can consider. One is like the individuals can be considered as agents, and computer scientists want to build software agents because they can automate things, they can automate this decision making process. The agency is something you can consider how we can denote that capability, right? So fundamentally agent is nothing but a decision making unit. It can be physical unit like humans, robots, or it can be even like a physical units in the sense it can be a controllers. For example, we have thermostat in the offices, right? For example, like if you set like 29-degree, it will try to manage the 29-degree, which nothing but which has a controller in the backend, which keeps on understanding the temperature and then trying to control it with the help of some signals. So it can be robot or it can be even a simple controllers. In control system, we have like this PID controllers kind of. And it can be a non-physical entities which is fully built on software, which can be decision support systems. For example, like in the early days, there used to be expert systems, there used to be like fussy logic based systems, which are fully written in software. So this is actually I'm quoting it from this book, Algorithmic Decision Making. So this term, if you think, okay, agent is a very new term and it's been in the industry only after the paper React came. But the thing is, historically, for decades, the term has been used across different papers, maybe thousands of papers might be using this because like I myself have worked on something called agent-based modeling in order to simulate the drinking behavior of American population. For example, I want to understand if I'm launching a new product, I want to understand how this new product will be received among a specific community. For example, youngsters or college students specifically, or school kids, how the specific community will receive this particular product. Will they buy more or will they just ignore? So there, the agents are nothing but the individuals. And in the literature, you can see like people are using this agent to represent microeconomic agents, which is nothing but like how agents are behaving in markets, how agents are behaving in a specific social setup. As well as there are papers talking about software agents or soft robots, which is more of like carrying out a goal-oriented tasks. And the same paper, like the Introduction to Software Agents by Bradshaw, they like kind of distinguish like based on the level of agency and level of intelligence. And when both of them increase, they become intelligence agents. Otherwise, it can be like a very simple workflows or maybe like very predefined systems. But mostly like right now, currently we are more interested in the term intelligent systems. So intelligent agents or LLM agents, because LLM is what talk of the town, and then that's just actually the representation of like artificial intelligence these days. So in that case, I want to put it very simple notion that from my like kind of control system laboratory days, because I come from the uh, background of control engineering, where this notion, right? There is an agent. That agent continue to engage or interact with an environment. Consider agent can be a wall controller or a temperature controller. Consider a temperature controller because that we could see in our offices every day. And the environment can be the room that we in, or maybe the chemical processes. For example, since I worked more in the process control side of things, I mean, in my college days, in labs and projects. So there is a valve control and or a temperature control, and we have a chemical process. For example, in the chemical process, we always wanted to maintain a temperature. To maintain a temperature, either we can use a valve so that we can keep on add a water so that the temperature is getting balanced, or maybe we can use a temperature controller based on the current input. We can increase and decrease the temperature. Consider like how you do in your induction stove. So there are two things. The agent is sending the control actions, which is nothing but some sort of signals, which can make difference in the situation in the environment. For example, if one signal is going on from the agent to environment, the environment's temperature might be altered, adjusted. Once that is getting adjusted, we continue to observe that, okay, I reduced the valve opening by this much. How much temperature I'm able to reduce it or increase it. So that is nothing but the observation. So the observation can be anything like states or rewards, right? So continuously we observe both, like state, what status it is there, and whether if we are doing it in a right way, we'll get a positive reward. If we are doing it in a wrong way, we'll get a negative reward. For example, I'm adjusting my wall. Because of this valve adjustment, my environment's temperature, the chemical process temperature, reduced to, let's say, 85 degrees Celsius. But I want to balance the temperature at 100 degree Celsius. So I want to achieve 100 degrees Celsius by, but I'm just maintained 85 degrees Celsius. So this 85 degrees Celsius could be the state because we are observing, okay, what state we have reached by doing this valve adjustment, and how closer are we can be the reward. For example, if we are, if you can make some calculations, but directly you can consider, okay, if I am close to the, the target temperature, I can get better rewards. If I am getting deviated from the temperature, I'll get a negative rewards or a very less rewards. As an agent, right, it always wanted to maintain this rewards maximized. Consider that. So that case, even if you think in yourself like, okay, you as an agent and you work in a game, or you're playing a game environment, or maybe you are in this job market, which is an environment, you always wanted to do such actions which can make you to reach a better state as well as to get better rewards, right? Because rewards define the state, whether it is best or best. So let's say the same like illustration, we can consider it for thermostat as well. So let's say there is a thermostat, and the thermostat is being fixed in the environment, which is the room. So the thermostat continue to observe the temperature through the sensor. It will measure, okay, how much, whether it is 23 degrees Celsius, 23 degrees Celsius, or 29 degrees Celsius. And the thermostat will have its own logic to do some sort of calculations and make a decision that, okay, this much is what I want to control the current flow to the AC, or maybe there may be some sort of actuation, let's say some controller, like with current flow or maybe something else, so that it performs that particular action and it keeps on capturing that. Like, so here we have only one objective, that I want to maintain the temperature in a specific level, let's say 23 degrees Celsius or 25 degrees Celsius. For that, I have only one action, which is nothing but I'll increase or decrease the current flow. Based on that, the motor will run, or maybe some logic might be there in the controlling side. And there is only one single input, which is nothing but how much temperature currently measured in the room. So it's a single objective, single action, and single input. So if you could see the paper that talks about the agentic AI and AI agents, they brought the differentiation between a thermostat versus a smart controller. So actually, the difference between both of them is not the term, but it depends on how many objectives it is handling. It is just to control the temperature, or is it something else? For example, you consider a control set as they claim. So in that, the logic getting extended, which means it is not just going to measure the temperature only, but it will also observe what is the time, what is the schedule of a specific person, or something, a calendar, a lot of things. So you're just going to get the signal from different sensors or different connectors, right? Multiple inputs you are getting it. And the same way you want to send multiple outputs to the environment. The environment can be, is it not just room now? It is room with multiple other applications. Room which has fan, light, and fridge considered, right? So in that case, the action, right, the control action from the agent will be multiple, which is like controlling the fans, controlling the lights, refrigerators, or something else, or maybe the notification also. So multiple inputs, multiple outputs, because we have multiple objective, which is I need to maintain luminance like this, or I want to use the fan also along with AC maybe, or I want to send some notification, and I want to defrost my, let's say, my refrigerator. Just consider it, right? So all such things can happen under one persona itself. You may wonder, okay, these many tasks we need to do. Do we need multiple agents? Need not to be, because for this you may not need to do multiple different persona of sorts. You can simply consider like, okay, one function. Consider it like there is one function that takes multiple inputs, do some sort of logics, and sending you the output. So in that way, we wouldn't even require multiple agents performing a task, right? Because we'll talk about that, what kind of scenarios multiple agents would look like. So you can think of this as a functional program, right? It's just a function. But this agent can be clearly defined. For example, agent will have a program and it will have its own architecture. Like how in a function there will be a logic as well as there will be some sort of a structure that we wanted to maintain. Structure is okay, I need to take data from here and there and do some sort of processing, and then I have to follow this logic to take some decision, right? The same way is what an agent can be defined as an equation, like it has a program and it has an architecture. Let's see like what this program and architecture would look like. Okay, so I would say, like, I would suggest like you can refer this Russell and Norwick's book, because they start the book with defining what are intelligent agents, right? So when the agents, right, like the term agent become more and more human over the time, because we want to solve the problem of artificial intelligence, or like solve the problems that is more of what humans face, right? It's not just like process based problems, but also which involves human like thought processing or human like decision making, right? So that's why the term, now from here onwards, I want to bring this term, focus more on the real world problems that humans would involve and solve it by reasoning out, or maybe solve it by like taking right decisions, right? Because but at the end of the day, you can consider the notion of agents for economics, process control, robotics, as well as for usual human problem solving. So, for example, like I just like the nostalgic thing I just want to mention is like years back I presented this like how can we simulate agents, especially in the environment, like the COVID environment. Like let's say the bounded city is going to be an environment where the human beings and the frontline workers are going to be agents, and then every agent will have its own property as well as the behavior, right? For example, if a specific agent or if a specific person is more into like travel free or like kind of a socialized, like, oh, they will be like roaming around the city, and based on that the interactions would vary with respect to the environment, and then the result would also vary, right? So it's like you can use this agent as a framework to formulate a lot of problem spaces. So coming back to that, let's say we have our LLMs, which are going to be part of these agents, and we have the world or the workplace or a specific code environment, right? Development environment, or maybe a workplace which consists of multiple applications. For example, my Google Drive, right? I have Google Drive, Google Docs, and multiple other things, Google Calendar and Mail, Gmail. That becomes a very perfect environment that I'm getting signals, I'm getting like different information. My agent is going to understand that and do some sort of tasks. As simple as that. For example, before going into that, like the agent, as is mentioned, like it's an architecture and program, right? Where the LLMs are going to design this particular program, or like taking care of the program, which is like how things like the thought process related stuff, or maybe like data handling and all such things will be taken care of the AI program, how it should go, like the steps involved and the other entities, other ingredients required will be taken care by the humans. Like we'll design it. So the backend systems can be think like humans. It can think very rationally also, because these are all things I've taken from Russell's book. As well as like they can act like humans, as well as act rationally. Because not all the situations humans think rationally, right? There can be like humans, they'll have that bounded rationality, or they'll have like irrational things as well. So these kind of things you can consider while you simulate a specific situation. For example, you want to simulate a specific market condition. In that case, not all the humans will be taking decisions very rational manner. Okay, I got salary, I'll spend this much amount in stocks, this much amount in my savings bank account. Not everyone will do the same, like maximizing their impact, right? So that's why like there are different notions. But to put it simple, now this agent wants to do right things at the environment so that it can yield better results. For example, we would have seen a lot of coding agents. Consider coding agent, the environment is going to be IDE as well as the user. For example, user gives continuously giving inputs. For example, I myself as a user, I'll say like this code is not working, there are errors, the structure is not so good. Of I'll give a lot of inputs. That goes to the agent as an observation. The same way, consider an IDE. In that IDE, an agent can understand whether the outputs are good, whether the errors are coming in, or maybe something else like whether it looks good or not, like the structure, many aspects of the code and its outcome can be directly perceived by the agent itself. You don't need to like think like, okay, do I need a computer vision? You may or may not, but very simply, if you want to put it, these are all direct text that can be easily connect with the agent, which is nothing but the program and an architecture through some connectors or APIs. And based on that observation, the agent is actually creating a specific code and that runs results. We keep on do this. So what could be inside that agent? So there will be a program. Program is nothing but, for example, for an LLM based agent, program is nothing but a prompt, a system prompt. Consider a system prompt is a program that we can control. And sometimes we might need memory also, because since we since this is going to continuously operate, right? Through and through. For example, like I'll write the code and understand how it progressed, how good is that as a state, and as well as the user comments, right? If the user is saying, hey, it's very good, like, which means I might get very good, like, kind of rewards in the sense like this feedback itself is like inherently okay, signaling that, oh, you're doing good. So in that way, sometimes to manage this kind of continuous conversational conversational way of operating would need a better memory management, because I want to continuously see what did I do 5 6 conversations back, did I miss any specific features or not. So that's why we add the memory. So the program and memory. So it sounds like a brain, right? In brain, we also have memory as well as our brain performs some processing, right? It's more of like RAM and ROM. So in that case, there will be a continuous interaction. Like I'll take the memory. So that's what people consider as the agentic RAG and all, right? Like it continue to retrieve from the memory. It will take, okay, 2 conversations back, I received this particular request, or maybe I received this particular conditions that I should not use this specific font or this specific images. So those kind of things and all we can continue to take it from memory. So actually, in reality, there are different types of memory that we'll get into later. For now, we can keep it simple. Okay, the memory will continue to give me different references over the time, and sometimes I might need to use some tools, even for as an agent, let's say myself as an individual, to do something. Like I may not be just like doing my for what, like I just think with just the thought process, I may not be able to do anything. I might need to use some medium of action. For example, right now I have read a lot of things and I have this thought process, but I want to, what's that, I want to like interact with the environment, so I'm using this medium. The same way in specific scenarios, for example, in the application building, it is not just like getting the code out, writing the code only. Maybe we need a compiler, or maybe I need some other connectors to get the data, or like authentication related tools. You can consider a number of tools. For example, usually people mention this get weather as one tool. Okay, if I ask an agent, okay, what is the temperature in San Francisco? It's a very usual thing that people always use. Like, what's the temperature in San Francisco? To answer this question, the agent cannot do the best thing just with the memory or just with the program. Because in the memory, you'll all have the old temperature patterns, some learnings. For example, okay, in summer, temperature will always be high, summer temperature will be in this range. But we are not able to get the real time thing. or we're not able to get the factual stuff. So for that, I might Google it or I might use the phone. The same way, for the agents program, it will not be able to get the real time things also, the required fixes, or maybe the data might come from some other places that we need to use it on demand basis. That only we use these tools, right? I'm not going to use like this laptop or this video medium all the time. I'll use this whenever I want to convey specific thing in a way. So consider when I want to do authentication. Okay, I've written the code authentication, but to make this code to work on this application, I might need to register it on Supabase or Stripe or something else. So that's where the notion of tools come into picture. So now an agent becomes complete, like it has a memory, it has its own program, and it has its own list of tools, right? And what could be inside the program? I keep on saying program, program, program. So program is nothing but like how a problem could be approached and how it can be taken forward to reach the solution. For example, a program, if I'm asking for write a HTML format of my resume, it might go through user requirements and it might need to plan initial steps and might ask, do you want this or this kind of like requirements? And then might have some scratchpad kind of things like, okay, let me draw this and then I'll first do this. So those kind of schematic architecting. And then further, there's a lot of things before, let's say, dispatching the output. You can do the same. You can actually feel the same thing in your, let's say, any of the thinking chatbots like 2.5 Pro or Claude AI, which extended thinking, or ChatGPT with O3 or the O1 side of things. Whenever you ask something, for example, deep research, if you take, you put something like in ChatGPT deep research or Gemini deep research, you ask something. Let's say write a working paper or write a one-page document on agents. It will go through that and it will come up with a plan. Okay, these are all things I'm going to search. Would you like to consider? Right. So such kind of way of approaching the problem is there, right? So that's what we mention it as program, and then that is what you're going to control in your system prompt, right? Okay, this is how it should go. Like you have to always ask for, like, let's say, the requirements first. Once the requirement comes in, then you analyze the requirements and then plan something. So it's gonna be mix of multiple things like chain of thoughts. Chain of thoughts is nothing but like, I mean, instead of directly shooting up the answer, you're considering multiple things and then you are going to do the step-by-step approach. So it's more of like what Daniel Kahneman mentioned, system two. The system two of our brain or system two of an agent will be more slow in thinking, more deliberate, and more in terms of how we can do better in problem solving, for example. And it will have the reflection in the sense like it itself will try to realize whether we are doing right or not, what are the places we might miss something, and the critics as well as divide and conquering of the task. An internal monologue is something that we have recently seen in almost all these chatbots, right? So that's how like it defines, like based on the requirement, you can also define it like, okay, you have to first think step by step in this way, and then you have to come up with the initial plan or initial output, and then you yourself should criticize that and then okay improvise it. For example, you are building a lead gen or let's say marketing related agents. So it should not be just, I have seen like this example. Why I'm mentioning this example is many places people are saying this is a lead gen agent or marketing agent, but it is very straightforward thing. It takes some data from some Excel sheet and then write a mail in a very templated way and sending it. It is not doing a criticism or let's say step by step approach or maybe something else, right? So that's where it's up to you, like how do you want to uh, like define these thought processes would look like, right? And when it comes to architecture wise, because why this architecture is needed, it is not always actually this architecture I kind of touched upon in this itself, which is like an agent is not just a program or a prompt, but it also has an architecture which is having components of memory, having an access to tools. But I just wanted to put it from the literature, like how people have to put it in a very comprehensive manner and call it as cognitive architectures, because cognitive architecture is nothing but how we need to orchestrate this problem solving things and what are the building blocks we would need. For example, here I just mentioned memory and set of tools and program, but if you want to deep dive, we can see the progression. For example, a very straightforward LLM is nothing but it is requiring the input. It is getting the input and giving the output. There is no continuation like, okay, whether it performed very well or not, or whether like they are sending along the feedbacks or not, nothing. But the language agents are coupled with the environment. It continue to make the observations. For example, consider even the chatbots as an agent, but with very low autonomy or agency. Because as long as you don't say anything, it will not perform, or like there is no goal. It just like has to like reply back what you ask for. But to keep it simple, the LLM agents are like simply the LLMs coupled with the environment so that it can observe the inputs or the signals and then it make actions, and then again the environment can give the feedback or the further observations. Instead of just keeping LLM as the 100 percentage of operating system, we are adding extra things to it, and we call it as cognitive language agent. And that is how the cognitive architecture is also start evolving. Because if you see in the C, we have the agent like LLM, which can take input and output, but also we have what? Like we have memory and we also have the reasoning. So that's what we see here. Like it's not just like a LLM that gets the input and give the output, but also we have the memory as well as how the program also should look like, which is like all these things are like part of the reasoning. And we have like a list of tools as well, right? So further, this paper from like the archive that I've taken, named like cognitive architectures for language agents, they add more elements of memory. If you could see, the memory is not just like, let's say, everything dumped in one place, but also the memory, we have it like a procedural one, which is nothing but like, as I said before, like the pre-trained LLM as well as the code or the prompt sits here. Along with that, we have, let's say, the semantic memory and the episodic memory. So it's like episodic memory is nothing but capturing the important events. For example, if you put the agent as a customer support for your customer, for your client, there may be a lot of n number of important events would have happened. So we are just keep them in the episodic memory. Let's say like important things. We want to retrieve it. What kind of learning that we happen to have over there. And semantic memory is like, let's say you're extending your organizational database or your organizational contents and knowledge bases. So in that case, let's say whenever the observation comes in or the input comes in, it creates a proposal. Okay, this is what I want to do, and then it evaluates different things, and then it selects the best out of it, and then performs the execution. For example, you consider there are a lot of things, right? Like automatically ordering, let's say, booking hotels kind of examples, or replying back to the customers or making the follow-ups. So in such cases, you think, okay, I have to do something right now. For example, I have to reply back to this mail. Like you can think of like, okay, I just need to come up with a proposal. This proposal itself might list on, just I just shouldn't write a very like very plain reply, but I need to check certain facts. So I might need to call the tools like a specific Google Docs, or checking the recent stock movements using some tool. let's say, an API, and also ask for approval kind of thing. So it goes hand in hand, right? So this is how people have arrived to an architecture which is centered around this cognitive functions. I should not just like, oh, get the input, send the output. It's more of very deliberately crafting this decision making procedure. So in that case, it is becoming more and more uh, taking the ownership of decision making. So that's where the level of agency is getting increased, right? Till this, if you could see, it's like how the agent's capability is getting improved and how the architecture is evolving. Like how, for example, you just being a human or just a jobless guy and to an executive. So when you progress in this, your authority and also the degree of freedom to take some decisions, as well as let's say sort of idea, okay, what should do next. So such things is getting increased, as well as whatever the knowledge that you have, whatever the access to the resources, the tools is becoming more and more improved, right? For example, you consider a butler agent. For example, I always say this term butler, which is like which need not to check multiple things, which just need to do very specific task, right? Just collect basic information from the help desk, like from the front office operations, right? It may not need a number of details, but let's say there is a personal secretary kind of agent which needs to share, let's say, different details, everyday updates, catch ups, minutes of meetings. It got to do a lot of work. It has to decide a lot of things and plan out multiple. So in that case, only the responsibility, the level of what is that? The level of tasks, right? That is the only thing that varies, and that doesn't mean the new term is coming in. The agent that performs front office tasks and the agent that performs personal secretary or the, let's say, CEO office or a CFO office tasks are not making a difference in the definition of agent or the fundamental expectation from the agent. Only things, the roles and responsibilities, the persona, as well as the resources are varying because of the task, because of the problem that we are intended to solve. That's it. It's very simple to keep. And there are definitions, actually, the main definitions that people give for agentic AI is agentic AI involves multiple agents, but AI agents are individuals only. But that is baseless because the need of the multiple agents or single agents is depends on what we want to do. It's not depends on the terminology. For example, in multi-agent systems, we want to bring multiple personas of agents to simulate something or to perform a task. For example, if one agent can't do all these things effectively, or if you as a developer can't manage multiple tasks with only one agent, because if you think like in a development perspective, you cannot define multiple personas, multiple behavior with one agent itself, because it's going to confuse multiple things, or maybe you will not be able to manage the program itself, the agent code, if you say. So that's why we want to have this multi-agent architecture or multi-agent systems where you can have multiple agents, they can collaborate with each other, they can compete with each other, they can criticize, they can cooperate. For example, you want to have a newsletter making agent system, right? So it need not be like one agent does crafting the outline and then writing things and then write draft and validating it and final proofreading and all such things. Maybe you want to have a different agents, like one which will always explore the online and then come up with the topics. The another one will come up with the outline. The another one will do the devil's advocate thing. Okay, will this work out or not? So in that case, individual agents has their own persona or the behavior and the access to different devices. For example, it's more of like divide and conquer kind of thing. Let's say you want to create a newsletter, so you want to keep it very simple and easily manageable, so that you have multiple agents, so that each agent can have like very confined goal or achievement, things to achieve, as well as very sane and sorted things to deal with, right? So that it won't get into trouble or confusion. Still, the environment is going to be the same, what user is giving the approval or not, for example, right now, or what comments that we are getting, feedbacks, or maybe if you think in a very broad spectrum, let's say the environment can be this very like a realistic Substack environment. Let's say the agent just keep on minting the outputs and sending it to the Substack automatically. Over the time, it observed, okay, what are the comments and what are the, let's say, comments, and then likes and reposts are getting it. Based on that, it captures something. Or maybe it can even understand what are the different blogs and posts that are getting more views or maybe more engagements. So these are all the signals that the multi agents can take. Maybe there can be a brainstorming. Agents can observe all these things. Okay, can we do this or that? So this is how we are like. This is how the agency and autonomy is getting increased. When you consider multi-agent system and the environment as very confined thing, that okay, I am going to be the environment, which is I'm going to receive all the I myself, which is the man human, as a part of the major part of the environment, that I'm going to give commands to the multi-agent system and get the newsletter, and I'll read it and then give the command. This can be a low-level autonomous thing, because like we have to give the commands and all such things. Think of this same agent put under high-level autonomous thing and high-level agentic thing, right? Autonomous is like automatically performing all such things, and then agency is like itself is taking the decision that okay, the next topic I can take, I can write this next topic. I can. It's more of like how proactively I'm planning stuff, right? So in that case, the same, the multi-agent system is getting into the next level of environment, the complex environment, that it is not going to wait for human input, that hey, write blogs on this and that, or let's say you have to have this kind of structure on all such things. Instead of that, it is directly going to observe things from Substack itself, what kind of contents are going in, or what kind of trending topics, or how people are even writing. A lot of things it can really observe and adopt, and then does that. So in that case, it just increasing its capacity. But still, it's an agentic system only. It's still an AI agent only. And it makes sense as well. So that's why I want to put it in a very simplistic way, that with respect to LLMs, LLM based agents, there is no big hierarchies or different nomenclatures to be studied or anything. You just think in terms of a building blocks or the fundamentals. I need to build an agent, and that agent should work very good at an environment. You just study what kind of environment is it. Is it just me as an individual is going to receive the inputs, so receive what my agent is doing, and then sending it, or if it is a very confined space like Google workspace, where I'm going to get different mails and then going to reply back, or maybe if it is an IDE, or if it is a huge ecosystem of environment of Substack or social media, where we are automating things like okay, continuously observe, plan, and then come up with a new content, post it on this complex environment, which is Twitter or Substack, right? Same way, how my agent should work. Should it just directly mint the output, or should it get into a deliberate planning, validation, and execution side of things? Should it require a number of resources? Should it need to hold things in this memory or not? So it depends on the use case, but by definition, by objective, by practice and theory, it's all just agent. And depends on it, it can be one agent or multiple agents. It's as simple as that. Don't think too much, or don't, let's say, It's not thinking too much. It's more of like getting diverted or having like the overwhelmed mindset and undervaluing ourselves. Oh, okay, I don't know this. I don't see. It's very simple. Okay. So from this mindset or from this intuition, you can really think, okay, how can I build this simple agent, right? In code wise, I guess I can come up with another video that, okay, how can we write an agent with very plain Python, not using any SDKs or like agent frameworks? Because it's very simple, because we know the logic. An agent need a memory, agent need list of tools that can be executable or can be callable, and then it need a program, like a thought process how to approach it. And it might need the couplings, like how I can, let's say, how I can connect myself with the agent can connect itself with the environment. Now it can continue to receive the, let's say, feedbacks or something, right? Maybe we can, in the next video, we can try to do the exact thing, right? Before that, I just want to show you that, like, let's say this is same as like how in reality also multi-agent systems are nothing but our teams. That's what I want to put it. Like in our teams, it's like people have different roles and responsibilities, and then sometimes we compete each other, sometimes we cooperate with other teams, and we always wanted to come up with better outputs, such things, right? And I want to present this few interesting reads that, like, if you have time, like, you just slow read things, right? Take some time, take a printout, and then read like this, react, how this reasoning and acting, right? As I said, inputs are going to come, how the planning or some sort of like reasoning works, and then we can do some sort of like actions. Actually, they have a benchmark or something like web shop where they are testing it on this shopping kind of task. And before this, the paper from Andres Karpathy and his team, the world of bits, they actually did a very extensive work on how we can build agents that can work in web environment. They actually collected a lot of simulated data, or like with the crowdsourced data people, and then they built this data set, as well as they trained reinforcement learning based models, because at that time there's no like neural network model that has a very good reasoning power, right? So that to match with that, like they trained reinforcement learning. But the idea is very simple, like they want to test this web-based agents to book something or to give inputs or to do something on the web interfaces. Let's say a drop, like a dropout, or like a, do like a from to form filling, or a select specific menu based on the input. And they wanted to evaluate it. How good are they doing it? And this one, like the Camel, is one good platform that brought up this idea into execution. They brought up the idea of multi-agent systems, right, into like the current practice. And they, in this paper, they have talked about the role playing, because when the multiple agents are coming into picture, how one agent can communicate the another agent. Right now, we are talking about the A2A protocol or M2P, sorry, MCP, such things, right? But they have talked about like how one agent can communicate with another agent, as well as what kind of, how this role playing can be brought into picture. Such things they have talked about. And then the recent paper from Stanford, Human Centered AI mission, which is they're actually simulating 1,000 people with LLMs. The approach they have taken is very interesting, because they have used the recordings, interview recordings of people, like how they answer, what are the thought process. Based on that, they are trying to simulate. Actually, to mention it, in one of the hackathon, I tried a similar method to do a generative agent. It's again LLM agent to simulate humans, but the problem space that I've taken is to simulate enterprise social network. For example, this idea, we wanted to like simulate how people in same company would network, how would they find their right companions or matches based on some vibes. Right? We want to simulate, like for example, based on some interview, let's say for some 15 interview questions, form-based questions. Like we want to record like what's the personality and their intent, and then their focus, and based on that we did that thing. And it's like very simple. Like you get more input from the interview forms, and then you analyze their behavior, like based on the big five or INTJ kind of things, and then you make it as a dynamic prompts, a system prompt. Hey, you are let's say very extrovert guy with ambitious goals, like getting into fan companies and always looking for collaborative friends and such things. Likewise, we try to simulate individuals, and then individuals will try to look for the other agents who are matching the vibes, and they'll have the conversations. If the conversation seems to be fine for both the agents, they'll say like, "Hey, this is good," and then that report will be given to the users, and then they'll select, okay, based on the agent to agent communications or the interactions, these are the top two people you can connect with, and you can vibe or you can collaborate. It's an idea, and we did it's kind of a semi-working prototype and presented in the hackathon. And this idea of simulating human behavior is something like a few of the Y Combinator companies have also taken as a problem statement, and they have built it as a product out of it. Like there's a company called AI Societies, like they simulate the LinkedIn audience for any content that you type, any content that you're gonna post in the links. Let's say I'm typing something. This typed content will be validated against my simulated community. Will they react positive to this? Will they like, or will they comment? Will they repost? Likewise, they are trying to estimate how much engagement that I would get. I actually tried it once. So likewise, we have to consider agents as a framework that helps us to put our thoughts in a very structured way. Even let's say you are building a product or you're building a initiative, and that needs to be maximized with the better outcomes, you can still use this how agent would work in the environment. And if you get into a specific goal oriented thing and you want to build it with LLMs and VLMs or anything, you can still follow the same thing, and you can deep dive into the individual components based on how critical is your problem and what are the different components. Right? It's as simple as that. You yourself first think like an agent. This is what my agent would require. This is what the resources that I need to supply. This is what I need to have my action space defined, and then my environments to be considered. Otherwise, it will be keep on running behind some fancy visualizations. So I guess this helps you a lot, or at least to the extent, to have a better start in terms of like how really you can think in terms of designing an agent-based solutions or simulations. And if you have any questions or doubts, keep mentioning in the comments. If you find it odd, or if you find it, let's say, I find a conflict in this explanation or this notion of, let's say, definition, obviously you can comment, or we can keep in a very good conversation so that we can really make people to go to the basics, learn, try out multiple things, and come up with better understanding, and think and build like builders, not marketers. That's what I want to keep in mind. And also, I want to mention it to everyone. Thanks for watching. I'm a bit tired. Yeah.